Meet our Triage decision support system, a game changer in emergency healthcare. Built with CDIPs, it swiftly prioritizes patients using dynamic rules and user input. From working abilities to the Glasgow Coma scale, it ensures precise categorization. This user-friendly tool streamlines triage, optimizing resources allocation and improving emergency response efficiency. Welcome to the future of healthcare technology.
So we go to on to the problem background. So what was the problem of this project? Firstly is the mistriage in emergency situations. So we have recognized the high stake involved in the triage, where mistriage can lead to increasing mortality, morbidity, and medical litigation. Second is the challenges in current triage methods. So in this part, we have addresses the difficulties faced by medical staff in making quick and accurate decisions, particularly during mass casualty incidents which can lead to error. And last, predictors of under-triage. So in this part is specific conditions such as asthma and certain chief complaints. So the chief complaints are cardiovascular, respiratory, fever, and diarrhea, are commonly to be found as the predictors of under-triage. Next is the objective of this program, of this system. So the first one is to improve triage accuracy. So we aim to reduce the rate of mistriage by employing a standardized and systematic approach for evaluating the severity of patients' conditions, ensuring each patient is categorized correctly according to the urgency of their medical needs. Second is decision support for medical personnel. So in this part, we want to provide paramedics and nurses with an expert system that supports decision making, taking into account factors that have been identified as predictive of under triage, thereby enhancing their triage capabilities. Third is data collection and analysis. To collect and analyze triage data, which can be used to continuously refine triage protocols and the expert system itself, ensuring the system evolves to meet changing clinical and operational needs. Last but not least, facilitate training and protocol adherence. In this part, we aim to serve as a training tool for medical staff, familiarizing them with triage protocols and reinforcing the correct application of the triage criteria, thereby improving adherence to established emergency response protocols. Next is the methodology. The first methodology we apply is defining the knowledge domain. We begin by clearly defining the knowledge domain, which in this case is the triage process in emergency medicine. Second is literature review. So we have gathered many information from various academic case study from the website in order to see the current standard and benchmarks for triage guidelines mainly in Malaysia. Third is data integration. We have integrated essentials data such as patients' demographic, comorbidities, chief complaints, and other relevant data. Fourth is algorithm testing and validation. We have tested the system based on the data we gathered to validate its accuracy. And last is designing the decision tree. So we have designed a tree in order to get the structural rule to.
Moving to the tree graph, we have for this simple triage system, we have template will be used to register the patient name and IC. Then we will be asked the working room and the uninjured. If yes, then the patient will be sent to the green zone. If no, then they will go through the respiration section, which is still breathing, yes or no. If no, then we will check the patient airway position, breath sound and heat and chest movement. If okay, then he will be sent to the red zone. If no, then we'll recheck again, and if yes, then the red zone. If no, then the patient will be pronounced dead. So if the still breathing is yes, then we will check how much is the breath per minute of the patient. If more than 30 minutes, then he will be sent to the red zone. If less than 30 minutes, then we will test with the capillary refill time. If more than 2 seconds, then we will send him to the red zone. If less than 2 seconds, then we will test him again in the perfusion section, which is does the radial pulse present. Then if no, he will be sent to the red zone. If yes, we'll be do the Glasgow coma scale, which is GCS. If equal or less than 8, then he will be sent to the red zone. If he got 15, between 15 and 20, that means he will be sent to the green zone. Within the green zone and the red zone, he will be sent to the yellow zone. So that can conclude our tree graph.
We get the data collection from various resources that tell about Triage system like website, Google, people opinion, from YouTube or from experts like doctor. The purpose is for us to create the system based on the data so it can be accurate when we do the system. The fact or the goal that we set is expectant, which is victim unlikely to survive given the severity of injuries. Immediate, victim can be helped by immediate intervention and transport. Delayed, victim transport can be delayed. And minor, victim with relatively minor injury can assist in own care.
Result and discussion. As you can see, the program runs successfully because it can put patient according to the agency, according to the fact and the rule we provided to the system. It also can calculate for the Glasgow Coma Scale to put patient correctly. Conclusion. In conclusion, the CLIPS-based triage decision support system is a major step forward in emergency healthcare. It automates and standardizes triage, addressing mistriage, and ensuring accurate patient prioritizing in high-stress situations. Aligned with START approach, it improves categorization precision from prompt and appropriate medical care. The project successfully met its goal, enhancing triage accuracy, supporting medical staff decisions, and facilitating data analysis. The rule-based approach and the Glasgow Coma Scale contribute to precision decision-making. Rigorous testing, literature review, and method design enhance system reliability. Thank you.
So now we can show the demo. First we run the program, then it will ask to enter our name and there is a number, and it will ask is the patient walking and wanted. If the patient is okay, then yes. So the system will tell that the patient is in green zone because he can walk, so he is okay. And we reset. We run again. This time we try to answer no. No. Then it will ask is the patient still breathing? So if no, it will ask is airway position, breath sound, and chest movement okay. We will tell no to. Can airway be repositioned? We check if breath sound and chest movement are okay. We tell no to. So this will declare that the patient is dead because all we answer is no. And we try again. This time we try to use yes at here. Here pronounce the patient is to the red zone because the breathing is still okay, so it red zone not dead. And set and run. This time we try to say yes to breathing, mean the patient is still breathing. So it asks how many breaths per minute, so we just set to 20. The threshold here is 30, so whether it below 30 or above 30, so we try to use 20 first. This will ask what is the capillary refill system. The threshold here is 2, so if it will either be above 2 or below 2. We try to above 2 first. Not above 2. Below or equal to 2. We say yes to him. So the GSC Glasgow comma scoring, so we will score and we try to use 1 1 1. So the score here for the red zone is between 1 to 8. So the score here, the total score is 3, so it will go to the red zone. So we try to go above 2, 3. So it will tell that the patient need to go to the red zone. This time, yes. So we try to Glasgow scoring. We try to be above 8, but below 12. Below 12. So we try 3, 3, 3. So if it's 9 to 12, it will go to the yellow zone. Four, 5, 1. So if it above 12, so it will go to the green zone. That's all. Thank you.